This lecture is on Chapter 2, Plate Tectonics. In this one, we're going to cover convergent plate boundaries, and this covers the PowerPoint slides number 28 through number 41. Convergent plate boundaries are where two plates are moving toward each other or converging. So what happens when two plates converge or crash into each other? It turns out that it depends on the type of crust where the two plates meet. Crust can be oceanic or continental. So we are going to look at the first case, which is where we have one oceanic plate and one continental plate converging. In all cases, the heavier plate will sink under the lighter plate. In this case, we have an ocean plate that is converging with a continental plate. And ocean plates are always heavier than continental plates because of the type of rock that they're made of. The sinking process, one plate sinking under another, is referred to as subduction. So these are subduction zones, and when a plate sinks under another one, it's said the plate is subducting. This process destroys the lithosphere that sinks under, so in this case the ocean lithosphere. You can think of it as recycling because the rock that is pushed down into the asthenosphere doesn't disappear. It just is no longer part of the surface of the Earth, no longer part of that plate. And because of that, we call that a destructive margin because we are basically destroying an oceanic plate. This is a drawing of that kind of convergence. So we have the ocean plate here, which is moving in this direction and sinking underneath this overriding continental plate. There are several features that we see on all subduction zones. One of them is the trench. The trench occurs right at the place where the two plates meet. So we have the continental plate here and the ocean plate here, and the trench is right there. That's the deepest part of the ocean. Trenches in general are the deepest parts of the oceans. And that's because the overriding plate gets pulled down a little bit as the subducting plate moves under it, just from friction. A second feature that we see are volcanic arcs. And when a volcanic arc occurs on an overriding continental plate, we call it a continental volcanic arc. So that is all of these mountains that occur behind the subduction zone. The third thing we always see is melting, and that's what creates the volcanoes, and that melting always happens below the volcanic arc. This is a map just showing the locations of all of the subduction zones, convergent plate boundaries. So not only subduction zones, all of the convergent plate boundaries. And we're going to look at some of these in detail when we talk about geographic examples. So this is a simpler drawing of a subduction zone between continental lithosphere and ocean lithosphere. This is the kind of drawing that I would expect you to be able to locate these three features on. So starting with the trench, we're looking for the deepest part of the ocean in this drawing. So this dashed line here, that's the ocean. And the deepest part of the ocean is right there where these two plates are meeting. So that is the trench. Then we have a volcano here. That is the volcanic arc. And melting must occur directly below the volcanic arc to feed the volcano. So melting would be occurring in this area. Notice that it is right between the subducting plate and the overriding plate. That's where melting is happening. So a geographic example of a place where we have a subduction zone that involves an ocean plate and a continental plate is along the west coast of the United States up along Oregon and Washington. So these are the Cascade volcanoes. So in this is a photograph, Mount Hood, but in this drawing down here, we have that same subduction zone we were looking at before, but this one has been drawn more specifically to be the way we see this expression in the Cascades. So we have the subducting plate moving down here, and we have the overriding continental plate here. We have melting occurring here at depth, and we have volcanoes occurring along here. So this is the continental volcanic arc that occurs back here. The second type of boundary we can have, subduction zone boundary, is where we have an ocean plate converging with another ocean plate. So again, the heavier plate is going to sink. But how do we know which one is going to be heavier? The older plate will always be heavier. So in this case, we have the plate here. It has continental crust on this part, but here we have ocean crust and ocean crust and ocean crust, right? So the subduction is happening between this plate of ocean crust and this plate of ocean crust. We have our trench, deepest part right along where the two plates are meeting. We have melting occurring, as we would expect, and we have volcanoes occurring right along here. In this case, instead of a continental arc, we call this a volcanic island arc. That's because these volcanoes start out as volcanoes on the seafloor underneath the water. It's only after they have grown tall enough to be above sea level that we can see them, and then they are considered islands because they're not one continuous landmass. A good example of this kind of subduction zone where you have a island arc is the Aleutian Islands right here that are off of the coast of Alaska. So here's Alaska here. And you can see different volcanoes named along here. So they are all islands that have formed as the Pacific plate here is diving underneath the plate up here. So where do we find subduction zones? Well, we find them at convergent margins where we have one plate of ocean crust at least, sometimes two plates of ocean crust. So if we look around, we see we have a lot of trenches in the Pacific Ocean. So here's the Peru-Chile Trench right along here. Here's the Central American Trench right along here. So remember, trenches are always associated with subduction zones. They're one of the main features. Here's the Aleutian Trench that we were just looking at. We have a couple of trenches here making up Japan. The Marianas Trench, which is actually the deepest trench in the world. And the Philippine Trench is here. And then we have another trench here. So notice that there are a lot of these subduction zones along the Pacific Ocean. So this is basically the Pacific Ocean. We have the Cascades are right up here. They don't show up as a trench because the trench has been filled with sediment, and this is a relief map. So that sediment that is inside the trench and built up is kind of masking that trench. This is also known as the Ring of Fire. All of these trenches that we were just looking at that surround the Pacific Ocean is the Ring of Fire. Subduction zones have constant volcanic action going, so the volcanoes are active. Not everyone every day, but in general, you will always have active volcanoes in these locations when you have a subduction zone. So the third type of collision zone happens when you have a plate of continental lithosphere that is converging with another plate of continental lithosphere. So this happens when an ocean between two continents has been subducted away. So a good example to look at is the example of India crashing into Asia, creating the Himalayan mountains. So before that happened, there was this ocean between the two continents, India and Asia, and this subduction zone eventually destroyed all of this ocean here, and as it does that, it pulls this plate closer and closer like a conveyor belt. This Indian plate is sort of riding along, and eventually it ends up colliding with Eurasia. So you can see that having happened here. There's a time scale here. So here's where India was about 71 million years ago, and then it crashed into Asia initially about 10 million years ago, and it is here today, in this location. Here you can see a cross section where we see that Indian plate here, and we see the Eurasian plate here, and basically in trying to be on top of each other right here, we have created very tall mountains that we call the Himalayan mountains. When we have collision zones with two plates of continental crust that crash into each other, basically neither plate is heavy enough to subduct. They are both buoyant, both the same density, and both buoyant. So there's no subduction. Instead, we end up with two pieces of continental lithosphere that are on top of each other. And what that does is that pushes down and creates the roots of mountains that are deep and the heights of the mountains that we see above the ground. This creates big earthquakes, but no volcanoes. So in both types of subduction zones, we saw a trench and a volcanic arc as geographic landforms that were associated with subduction. For a collision zone, we just see these very large mountains, the Himalayan mountains, the Rocky Mountains, the Appalachian Mountains. The Appalachians are quite old now, so they're not as tall because erosion has brought them down to a lower level. But all of those mountains were created through the collision of two continents. So the Himalayas, the Alps, the Rockies, and the Appalachians, just four examples of collisional mountains.